This one vulnerability exposed over 130 million credit cards, took down the PlayStation network for almost a month, and continues to wreak havoc on websites every day. Now, if you haven't caught on, I'm talking about SQL injection. It's one of the oldest tricks in the book, yet companies still fall for it every day. In this video, I'll break down exactly how it works, how to exploit it, and the simple fix to ensure your application isn't next. To understand SQL injection, we first have to understand how applications store and retrieve information. Most applications use a relational database such as SQLi, Postgres, or MySQL. Think of these databases as basically a really fast, really powerful Excel spreadsheet. To read and write information from that database, developers use SQL, or structured query language. For example, this query tells the database, select all columns from the users table, where the username is admin. But here's the catch. Developers need to let you, the user, specify who to search for, and this is where the injections start to happen. So, normally you type your username into a box. Let's say you type admin. The application takes that text, ships it to the server, and the server asks the database, does this user exist? But how exactly does the server build that question? Well, this is where the mistake happens. Let's look at the code running behind that login box. Here the application receives your input, and here's where the fatal flaw occurs. The developer is building the SQL query by gluing strings together. Because there's no separation between commands and data, an attacker is able to modify the original intent of the query. Instead of a username, we type this. When the application glues this into the query, it accidentally changes the meaning of the command. Now, instead of our intended logic, which is to check for a username and password match so we can log the user in, the database now searches for a username which is empty, or 1 equals 1, which is a bit of a logic trap. Since 1 equals 1 is always true, it actually returns all records in the database. Because we're using the query row function on our database, this returns the first record from the database, which is usually the admin account, since it's the one that's added first. And just like that, you're able to log in as the administrator, without ever even knowing the password. So, logging in as admin is pretty fun, but you have to be careful when using this or 1 equals 1 logic. If you inject it into an update statement, you'll accidentally override the entire database. I accidentally learned this the hard way on a penetration test a few years ago. So the website was a mess. There was heaps of vulnerabilities in it. It was really fun for me, probably not so fun for them when they got the report. But so one of the pages was an update my profile page. And so I was just messing around with it, trying to find cross-site scripting, just pasting in SQL injection payloads. And then I kind of like moved on and started testing another area of the app. Well, then it was the end of the day, basically. And then the next morning I wake up, go to work, and the client calls me at 9 a.m. Which is pretty normal. Sometimes they want an update. But straight away he's like, hey, we have a problem. And I'm like, oh, what's the problem? And he's like, every user in our database now has your name, phone number, address, and all those details. And I'm like, thinking like, what the hell? Like, I haven't even done anything. And then I open up Burp Suite and I'm looking at what I've sent, and I see it. I see the update, my profile page with the or 1 equals 1 payload in there. And the response from the server was a 200, which means, we did the update and you're all good to go. And so, yeah, by accident, maybe by lack of experience, I overwrote their whole database. Luckily, they had a backup. I didn't actually expect them to have a backup because of how bad the rest of the app was. But thankfully, they had a backup and they were able to restore. That saved the company and probably my job as well. Now, while I made this mistake, usually hackers aren't trying to destroy all your data. Normally they want to download all of it. This way they can use it to blackmail you, sell it on the black market, release it to everyone to boost their reputation. And the way they steal your data is through a specific SQL injection attack known as a union-based attack. To understand this, you need to know a specific SQL command called union. In SQL, the union operator allows you to combine the results of two different queries into a single list. Think of it like zipping two spreadsheets together. As long as both sheets have the same number of columns and data types, the database will happily glue them into one big report. Let's take a look at the application. Here I can search for my past transactions. If I search for barbecue, the database runs a query like this. It returns two columns, the amount and the description. Now look at what we're searching. We're strictly looking at the transactions table. But sitting right next to it in the database, like a separate tab in a spreadsheet, is the users table. This is where the usernames, emails, and passwords live. An attacker doesn't really care about your barbecue expenses. They want to reach over and grab that other table. So instead of searching for a description, they inject a union command to join those two tables together. The database sees the first part, which basically says find transactions with any description, and then it sees the union, executes our select statement, and merges the results with the transactions search. The application thinks it's displaying a list of transactions, but if we look closer, we'll see where the description should be. It's displaying some usernames. By simply asking the database to join two lists, we've tricked the website in displaying its own users on the web page. We could also do this with passwords if we wanted. But doing union attacks manually is so slow. In the real world, we use SQLMap. SQLMap automates the entire process. We simply give it the URL of the vulnerable search page and tell it to dump the users table. It automatically detects the injection, calculates the column, and within seconds it downloads the entire database. This is how data breaches happen. The website simply gives you the data because you asked for it in the right language. So how do we prevent all this? Well, we have to stop using string concatenation and formatting when building SQL statements and only use prepared statements. Notice the difference? Instead of putting the input directly into the string, we put a placeholder, usually a question mark. Then, to execute the database query, we first send the code structure to the database. The database then prepares this plan. It knows it's going to be searching for a user, and it's waiting for a value. Then we send the input separately. Because there's a clear separation between what is part of the command and what is part of the data, the database can no longer be tricked, and it literally just searches for a user whose username is quote or 1 equals 1. It obviously doesn't exist and the attack fails. If you build your SQL using parameterized queries, your data will stay safe and you won't be in the next headline. Now you know how hackers can manipulate your database, but that's only half the battle. Check out this other video that I've made on cross-site scripting so you can learn how hackers inject code right into your user's browser. If you learned something new, hit subscribe. I break down security vulnerabilities every week, so be sure to check out the next one.